Good day, everyone. We have here our second problem for Chapter 6, Fluid Flow Measurement from the 4th edition of Fluid Mechanics and Hydraulics by 𝐷𝐼𝐷 Problems 6-19. A closed cylindrical tank 5 meter high contains 2.5 meter of water. A 200 millimeter circular orifice is 0.5 meter from this bottom. What air pressure must be maintained in the air space in order to discharge water at 20 HP? So we have here the given for the problem. Note that 1 HP is equals to 745.7 or 746 watts, and 1 HP is equals to feet times pounds per second, and 1 watt is equals to kilogram times meter squared times over is cubed. So the given of this problem is H is equals to 5 meter and the diameter of 2.5 meter in the orifice of 200 millimeter, and we need to convert millimeter to meter. So 200 over 1000 is equals to 0.2 meter, and the y is equals to 0.5 meter, and the P air is unknown, and also the discharge is unknown. So to convert 20 HP to watts, we must multiply 20 HP times 746, and we get 14,920 watts. So after that, we are going to substitute the given. 14,920 watts is equals to pi over 4 times 0.2 meter raised to 2 times 9,810 Newton per cubic meter times V squared over 2 times 9.81 meter per second squared. So we are going to multiply 0.2 meter times 0.2 meter is equals to 0 pi over 4 times 0.4 meter squared times 9,810 Newton per cubic meter, and multiply to V squared times 2 over 2 times 9.81 meter per second squared. And then we are going to multiply 0.04 meter squared times 9,810 Newton cubic meter. So we have the answer of 14,920 watts is equals to 0.03142 meter squared times V squared over 19.62 meter per second squared. So the remaining is 14,920 watts equals to 308.19 Newton per meter times V squared equals to 19.62 meter per second squared. And next, to get V raised to 3 for the velocity, we're going to multiply this to, so 14,920 watts equals to 0.03142 meter squared times 9,810 Newton per cubic meter times V raised to 3 over 19.62 meter per second squared. Multiply by 19.62 meter per second squared over 9,810 Newton per cubic meter times 0.03142 meter squared. And then we need to cancel out the same value in unit. So cancel this, cancel 9,810 and 19.62 meter per second squared. And then we need to write the remaining value. So the remaining value are V raised to 3 equals to 14,920 watts times 19.62 meter per second squared over 9,810 Newton per cubic meter times 0.03142 meter squared. So as we note before, the value of watt is equals to kilogram times meter squared over S cube. So 14,920 kilogram times meter squared over is seconds cube equals times 19.62 meter per second squared over we have note before the Newton is equals to kilogram times meter over second squared. So 9,810 kilogram meter per second squared is equals to cubic meter times 0.03142 meter squared. And as we multiply this, and we have the answer of V3 is equals to V raised to 3 is equals to 292730.4 kilogram times cubic meter over S or second raised to 5 over time we multiply 9,810 times 0.03142 meter squared, so the answer is 308.23 kilogram per cubic meter over S squared or second squared equals cubic meter. So cancel the same unit and next we have V3 is equals to 292730.4 kilogram times cubic meter over S5 divided by 308.23 kilogram per second squared. So cancel the same unit and write the remaining value in unit. And to cancel the V3, we're going to cube root over V raised to 3 equals cube root of the total of this 292,730.4 divided by 308.23, and we get 949.7141745 cubic meter over S raised to 3 or second cube. So cancel and cancel the same unit. So the cube root of 949.7141745 is equals to V is equals to 9.829 meter per second. So that's all for this video. Thank you for watching, guys.